So let's first study then the load drive requirements, because that is maybe not at all very clear what the load drive requirements are. We have given some numbers, and this is called. You have had this specification. It was on the first page of the lectures of the antenna, the application specification, and usually in industry you get a thing like that. They call it a first spec, a draft. And in this draft, there are numbers that are targets given by the systems engineers. Let's say this is what we want to have. And of course, it is not always as fixed as it appears to be. It's usually something to discuss. Well, what is the price to make it? Can we make it? And since the systems engineers don't have the detailed knowledge from the electronics, usually it's a task for a designer of electronics to do this investigation. So let's start. The load drive requirements. So we want to have 0 dBm in 50 ohm. 0 dBm means 0 dBm. Milliwatt is the 0 dB reference level. So it's 1 milliwatt in 50 ohm. That's a common way of saying this. 1 milliwatt in 50 ohm means 225 millivolts root mean square across 50 ohm. But our amplifier is not going to drive root mean square values. It is driving peak values maybe. And now the question is, what is the peak value that it needs to drive in this 50 ohm? Is it like, assuming that it is a sine wave, then it is about square root of 2 times the RMS value? Or does the signal more look like a Gaussian distribution, like noise? Then, if you want to have less clipping than 3%, your peak value can be 3 times sigma, the standard deviation. So it is much higher than for a sinusoid. So this is a question that might become interesting. So for a sine wave, we call this the crest factor of 1.41. And if you do that, and most of you took this like 320 millivolts peak, and then you need to drive 6.4 milliamp as well with this 50 ohm. But if the signal looks like has a Gaussian distribution like noise, then we have a crest factor of 3, and then we have to drive 675 millivolt, and that is 13.5 milliamps peak. This would be a nice question for you go back with the specification to the system design engineer, telling you what is it exactly that you want? How does the signal look like? What signals are we dealing with? Is it a narrow band signal? Then it looks like maybe more a sine wave. Is it a wide band signal? Then maybe it more looks like noise and a Gaussian distribution. And then we have completely different values. You see, there's more than a factor 2 difference between it.